Welcome to Digital Toolbox. Today we're going to continue the waffle definition by starting to laying out our structure onto surfaces. And before we get started, I'm just going to clean up the definition really quick by turning off the extruded sections. And then I'm going to turn off the grid also by turning off the items and the lines. And then I'm going to stay around where we have our planes that I just turned on really quick, and we're going to find the section from between the planes and our waffle structure. So we'll go to intersect, go to mathematical, and grab the B-rep plane. We're also going to need two of these so that the planes we're going to P for planes. Select both of the buttons and drag it over to the difference. So now the difference will go into B. I think I crisscrossed them when I brought them over, so I'll bring them back down and realign these wires. So now, as you can see, if I turn off the difference, there's our waffle structure that we're going to lay out onto our surfaces. And the surfaces are just basic 2-point surfaces that I laid out in Rhino, and they're in wireframe instead of shaded view right now. So I'll turn back on the difference, turn off the section. I'm going to go to parameters and grab a surface button. I'm going to copy and paste. I'm going to set one surface to each surface, and then I'm going to go to surface, go to utilities, grab the surface frames, connect my surface to each surface frames, and then right now that the U and the V by default is 10, and that gives us 10 intervals, not 10 frames. It's actually 11 frames. So this is not a very efficient way to lay out our surfaces. And we could connect the U and V according to how many structures we have. Right now we have 6 in the X and 6 in the Y, and we could put that into the U and V. But that will still only take up 6 of this the 121 frames that we've created. So what we could do is we'll count how many structure we have by going to logic, going to list length. We'll connect that to C, and right now it says L is ones and zeros. And to fix that, right click on the left L, click on flatten. Now we hover over L, it says we have 6 curves or 6 structures. We'll copy that and reconnect it down to the bottom set. So we'll use a one variable expression, and we'll go to the expression editor, and we're going to take the square root of how many curves we have or how many structure we have, and that number will give us a decimal most of the time, unless we use a perfect number such as 16 or 64. So we have a number such as 6. It will give us about 2.5, 2.6. So we want to round that up to 3. And to do that, if we click on display function list, there's a function called ceiling, and that returns the smallest integer greater than or equal to the specified number. So we'll type in ceiling, open parentheses, x, a caret, open parentheses, 1/2, close parentheses, and close parentheses. So we're going to take the square root of the number of structure we have, and then we're going to raise it to the greatest integer, and then we're going to subtract 1. Since we have to remember that this number gives us the number of intervals, not number of frames. So we always have to subtract 1 if we're going for the frames, not the interval. We'll click OK. We'll copy and paste this function. L will go into X, and then R will go into the U and the V. So now 6 structure will be laid out onto 9 frames instead of 36 if we use 6 from the structure A and structure B sliders. The next thing we want to do is rotate these frames so we can further maximize our sheet that we want to fabricate. So we'll go to X form, go to Euclidean, grab the rotate. The G will go into frames, and also the base plane will go into frames. And then we'll right click on A, go to expression, and type in rad A, which is changing radians into degrees. Remember to put parentheses around A after rad, commit changes, grab a slider. I'm going to edit the slider from floating points to integers, a value of 360. I'm going to copy and paste. One will go into the first geometry, second, and then to the second rotate. I'm going to turn off the frames since the rotate has the frames now. So now if I swivel this or move the slider back, you can see the frames being rotated. So right now we have 6 frames onto 9 geometry, but if we change one of them into 9 struts, a perfect number, it will still stay at 9, which will be perfect if we lay out our waffle with 9 in the X and 9 in the Y. So it's going to take a while to load, but here it is. And as you can see that the frames hasn't changed, it's still perfectly 9. So if we go to 10, it'll add an extra frame there, or an extra interval for it can accommodate up to the next greatest integer, or the next greatest perfect number. So that's how we start to prepare our surface. The next tutorial will orient our waffle onto our surfaces. And thanks for watching.